Ready? Oh, I can see myself. Oh, so you also tape the videotape. Ah, okay, good. Okay. Right, no problem. Okay.
So you have to stay seated if you don't mind.
Okay, so this is the best position.
Yeah.
Okay.
We're going to zoom into you.
That one. I see. Good. And maybe.
Wonderful. And it's recording. Is it on live stream or is it recording?
No, it's just recording.
Okay, I have to keep time. Right? So maybe I should wrap up just 30 minutes. Okay, so are we ready? Oh, okay. So again, good morning, everyone. My name is Fumihide Tanaka. Today I'm from Japan, the University of Tsukuba. This is a university located near Tokyo. And I'm from, I think, an engineering department. And there are lots of people working in robotics, particularly in the engineering, mechanical engineering part. And today I just like to talk, just introduce our works so far. And I think I should start from a little bit introducing myself, but I'm originally from an industry. And I actually, after getting a PhD in the field of theoretical machine learning, I participated in Sony Corporation in 2003. And as you may have heard of this, but just recently they announced re-entering this robotics business, but before that they basically discontinued this entertainment robot business until just this year. And I was a part of their research and development group for their original entertainment robots, like Aibo, and this small robot was a prototype, but that was called as a Curio. And as I said, after I got my PhD, I participated in this group, and but because they have to make an engaging robot product, we have to, after a lot of discussions, and we decided to start from basic research of what we call now as a human-robot interaction. Because at that time, as I said at the beginning, the most robotics, particularly in Japan, mainly focus on more like a mechanical engineering. So what we discuss relatively in the field of human-robot interaction or human-computer interaction was very rare at that time. So for example, the issue of long-term engaging interaction, this is such an important topic nowadays in this field, but at that time, few people realized that importance. So that's why we had to start from pretty much an exploratory study. And I asked my boss in Sony Corporation to start this human-robot interaction study. And I was fortunate to have a chance to start a collaborative study with the University of California in San Diego. And from year 2004, I was very fortunate to be able to spend 3 years of my life in San Diego and conducted this very exploratory fundamental study of human-robot interaction at a nursery school targeting very young children. And then, as I said, Sony unfortunately discontinued their entertainment robot business, I think in year 2008, and I had to move to the academia. And after I spent some years in the University of Tokyo, I joined the current University of Tsukuba 3 years ago, in 2014. And anyway, in short, I have been working in the area of social robotics or human-robot interaction, particularly targeting these young children. So I'd like to introduce our work a little bit. So this is actually the very first study I found the opportunity of entering this field. And this is exactly the exploratory field study we conducted in a nursery school in San Diego. And as I said, I think I'm originally from an engineering field, but as you know, that we engineer can develop something if we have clear specifications. However, for such an application like making engaging robots without let humans get bored soon, this is a pretty much ill-defined problem, and I believe we still don't have clear requirements or specifications. So that's why we had to start from exploration. So of course, we did a lot of brainstorming or workshop or whatever at the laboratory in Sony in industry, but we really felt our limitations. I don't come up with any more ideas or something like that. So that's why I thought that it's better for us to move out of this laboratory and do exploration at the real environment, at the daily real environment, totally uncontrolled and real humans. So instead of conducting any research or development in a closed room in Tokyo, we decided to move out of the laboratory, and eventually we immersed ourselves into this environment. And as I said, that through this exploratory study, our goal is to find any clue, any hints to attract their interest for a long period of time. So that's why I immersed into this classroom in an early childhood education center located in University of California in San Diego. And okay, you can see this. I think I should speed up my talk. But anyway, this is an infant class. They are younger than 24 months of age. And we bring our prototype robot on daily basis, as if I were a parent of their kids. But after I, leave my child, I sneaked into this back room and did an observation. So there, as you can see, that there is a back room. So I was inside there and did an observation. And sometimes I tried kind of a Wizard of Oz type observation. Meaning that I remote control this robot. But also I tried many applications developed by, many autonomous applications developed by Sony. So anyway, the goal is I tried all the best, not controlling anything. I tried all of my imagination and creativity to find any way to get their interests as possible or as long as possible. So this is pretty much an exploratory field study. And we believe we did find a lot of findings, important things to achieve long-term interactions. And some of the things, of course, I reported to headquarters in Sony because they were developing, they were really in the middle of developing this next generation entertainment robots. And also because I was in the academia, I was collaborating with the cognitive science department of developmental psychology in the University of California in San Diego. We also conducted scientific studies. So particularly this socialization process happening between these young children and the robots gained a huge public attention from these major media. So that's why we conducted a lot of behavioral analysis, tried to grasp the socialization process happening between there. Today, unfortunately, I think I don't have time to go very into each detail. But in short, we did find a lot of quantitative, not qualitative, quantitative evidence showing that, for example, the robots were getting to be treated as their peers. And also, I think sometimes we did a bit controlled experiment, tried to investigate the evaluation metric for daily human-robot interaction. I think then it was 2006 when this HCM HRI conference started, and I gave a talk at this inaugural event as to the evaluation metric, how to evaluate this daily interaction. And also, as I said, that because in University of California in San Diego, there were excellent academic staffs in the area of sociology, cognitive science departments, I was very fortunate to have the opportunity to gain advice from these people, and sometimes we found we also found this very, we believe, interesting effects. So, for example, this was known as a displacement effect, which was found apparently in the area of animal ethology more than nearly 6 years ago. But we found a similar effects observed in the this 21st ecosystem involving a robot. If you have interest, I can come back later to explain more detail about this, but maybe at first I should move forward. And also, sometimes we also did a bit more like an engineering study about all this, making an automatic assessment of the quality of interaction, meaning that this robot, we found that this robot can estimate how good it is interacting with kids by itself. This is pretty much a subjective judgment. How good he is interacting with humans using the haptic sensory informations. We found these very quite subjective evaluation made by human coders. Human coders were pretty much correlate well with these haptic sensory information, which was calculated by a very simple equation of linear regressions. So anyway, of course, to have that equations, at first we gathered a huge amount of real data by using the more than 100 hours of video obtained there, and the amount of labeled data obtained by human coders. But then we found that after this analysis, we found that, these quite subjective judgment are very well correlated with this haptic sensory information. And then we show that this equation can be implemented into this autonomous robot. So now the robot can judge, can assess how good he is interacting with humans by itself. And then if you combine this information with any machine learning techniques like reinforcement learning, in theory, we can obtain a robot that can grow by itself so that it's becoming popular to kids. Of course, but that's just a theory. And then I think here is another data. This is actually very important things. As I said, that this is an exploratory study, meaning that it's the most important for us to find insights or requirements for making an engaging robot. And here is here's a result. So we found that children really like to take care of robot. We did a lot of comparatory study with other robotic toy, for example, but we found that these behaviors of caretaking behaviors sustained longer. This is a very rare. And today I'm now showing that only a positive result, but I also have I would say that more than 90% of robot behaviors could not keep their interest longer than, I would say, 3 or 4 days. But here is a very rare exception. These behaviors were observed to keep happening even after 2 months, period. So that's caretaking behaviors And here is an example of those behaviors. On that day, I have to explain this. So on that day, there was an accident. On that day, I was testing this dancing application developed by Sony. And this is a completely pre-designed playback motions developed by the professional choreographers and programmers. But anyway, when I was testing these dancing applications, the battery of the robot was running out. That was, I didn't expect that. But because that robot was developed by this great industry, and they, of course, also developed a safety function. Safety function here means that if the robot running out of this battery, and it safely lay down on the floor and shutting down the operating system. And then let's see how this kid reacts to the robot. So, and we of course interviewed his parents, and their parents were very surprised to see this video, and they say that they had never taught their kids to do so. So this was the very first moment in his 1.5 year life to encounter such a situation. But of course, he could do that by himself, probably because their parents did the same things towards him. But anyway, this was really happening in a spontaneous way. And this histogram shows that these children's caretaking behaviors really happened, kept happening for a longer period of time. So we can say that this kind of vulnerable, weak robot could attract their humans' interest for a long period of time. So that's why just after now move back to relatively recently, but after I moved to the university, I started robotic applications for supporting education, and here is one of our research about an educational robot that utilizes the property of this care receiving kind of a property. So as you know, that now this education robots are becoming a very popular research topic in human-robot interaction and social robotics. And already we see a lot of researches or applications targeting these educational purposes. But still, most of these robotic applications are followed in this category, meaning that this is a robot which plays the human roles. For example, the teachers or parents. So these robots give instruction on kids or teach kids. And of course, some people say that, oh, this robot may not be able to keep kids' interest for a long period of time. And of course, maybe some of you may be familiar with, but there's also a very important discussion about robot ethics. So in fact, as far as I know, so far, there have already been published 3 times in Science discussing this ethical aspect of these robots. And in fact, in the first special issue published in 2008, and we were also criticized. And we are very seriously thinking about this. We recognize there could be this potential ethical issues. But at the same time, we also know that this robot has some positive effects. So we are wondering if there is any solution to solve these contradicted issues. And then one day, we came up with an idea which could resolve these issues. What if we do a reverse? We do a reverse. So here, instead of making a tutor robot, what if we make a robot or a computer that is taught by humans? So here, it's children who teach a robot. So children teach a robot. And of course, our ultimate goal is to achieve children's learning by teaching. Of course, with this, the same things happens in the human beings. So we already know that in our daily environment, this kind of thing, similar things happens a lot. So what if we designed a robot which can encourage this type of learning? So because this robot receives care, we named this robot as a care receiving robot in contrast to this caregiver type of robot. The reason why we didn't use the keywords like teachable robot were because we thought that the word care can cover a bit more broad behaviors than teach. So that's why we named this as a care receiver robot. Anyway, one of the reasons we did that was because we know that children likes to take care of the robot. So it could be more engaging for kids. And some parents also told me that, oh, I thought this idea is nice because, my kids don't listen to us at all. But if there is a robot which behaves, something worse than their kids could be nicer, meaning that if the kids see that robot, he or she would say, hey, robot, you are not supposed to do that. And eventually, that kids followed the parents' instruction. That's what the parents say. And we can see that, this could happen. And also, last but not the least, we believe that this idea could be acceptable to more people. We could say as ethically safer than this caregiver type or tutor robot, because we know that in principle, these kinds of things happened since hundreds of years ago. And we know that the kids take care of their dolls, and there are already have an application like a Tamagotchi or computer games. And also it's important to mention that this robot does not replace human beings. So teachers or parents are there, and this robot is just a tool to support their human education. So we think that the concept itself sounds nice, and then again it took a long time. It's a shame but after 3 years, I finally conducted a field study showing that the concept not just interesting, but it actually works. We conducted a field study at a professional English language school in Japan, and we did a controlled study, and we compared multiple classrooms, and in one classroom we introduced this weekly designed robot. But and the other rooms are completely human teachers gave lessons as usual. But in that room, we introduced this care receiving robot, intentionally weekly designed robot. In the kids. And that robot made mistakes. So for example, here, I think this classroom was for 3 to 4 years old, and the use of English verbs it was the topic of that class on that day. So a human teacher gave a lesson about how to use English verbs like play trumpet towards Japanese kids. And however, this robot intentionally made mistakes. So if the robot were asked, how do you say with this trumpet? And that robot, instead of saying play trumpet, that robot made mistakes like fly or dig or whatever, completely in the wrong way, which really made kids correct that things. Hey, robot, you should say you should say play trumpet. This is a trumpet, you know, so you should say play trumpet. And then after the lesson, kids learned how to say play trumpet. So this was found to happen in a significant way. We did a relatively strict control study in the framework of educational psychology, and we found a significant difference between the regular classrooms. And that effect happens not just on that day of the lesson, but also it lasts after 3 or 4 weeks from that from the day of the experiment. So I think we can say that at least this idea is feasible, and that the care receiving robot helped children's learning by teaching. So more detail was published in the very first issue of Journal of Human-Robot Interaction, published in 2012. Okay, so, and we believe that this concept is more general, can be applicable to other applications like teaching shapes and writing alphabets, or I'm particularly interested in emotional education. And just recently, even in the HRI conference, the people are reporting very similar findings. For example, the group of EPFL just recently reported a very impressive application of this teachable robots for kind of rehabilitation of the kids who has a difficulty in handwriting. And then I think I also would like to show you a commercial application of this robot. And I actually was serving as an, how it was called? It's kind of, I forgot, the consultant, consultant for SoftBank company before they announced Pepper. I was working for SoftBank for 2 years. I had a partial employment contract with SoftBank. I was serving as a consultant. And also the project leader of the paper asked me to develop a commercial application, particularly targeting young children for educational purposes. And they liked the idea of this care receiving robot. And then we developed an applications. And just today I showed you a video. Some of you may have seen this before. This is a So this video was made by the company, so includes many other things. So here, the paper didn't teach anything, but here, paper asked kids to teach red colors. So that's why the paper says that how is it like red, and kids like a treasure hunting. Kids find some objects, some red object, and teach paper this is red. It also has some other applications. This is a different applications. It's just make use of this robotic bodily motions. Oh, by the way, we didn't mention anything in this video, but as an advisor, I personally insisted the importance of this haptic interaction, because I personally also had conducted a lot of study focusing on this physical haptic interaction between humans and the robot, because I personally think this is very important. This makes a difference between, for example, the application on the tablet. If we use this robot, we should design a three-dimensional interaction in application. So that's why we put a lot of effort, for example, this high fives or any other opportunities involving the haptic interactions. This also related with this haptic interaction. I personally liked a lot of this direct teaching. But to tell the truth, this application was dropped at the final commercial version of this application. And that's because we could not prepare enough number of, how can I say, enough number of applications using this direct teaching. So because the company required us the number of vocabulary in the order of more than at least 30 or 40. We were required to make an application that can, in which children learn the vocabulary, more than 30 or 40 vocabularies. But we could not satisfy that conditions. We only could develop, I think, 8 or 9 vocabularies using this direct teaching. So that's why, unfortunately, this was dropped. This video was taken in the, this is not a final video. This is a video at the time of a press release, very first press release version. So it's not the final. It's not the final version. And then this company called Tryon is a spin-out company from SoftBank and doing real educational business of the use of robot for childhood education. I think they already have a branch in Tokyo, and they already started providing English teaching services. So anyway, just lastly, I showed the industry application of this education robot. I think these are more like an academic things, but as I said, that I personally think it's very important for a robot to involve these haptic interactions. Anyway, I think just I briefly mentioned, but we also found that these haptic interactions again could sustain longer compared with any other type of interactions. So for example, this graph shows that most of the kids' interactions, again, towards robot, could not sustain longer than 1 or 2 weeks in this graph. So the histograph, this is not a histograph, but basically the histograph, or most histograph follows this inverted U-like shape, meaning that at first kids are a little bit away from that robot, but then if they know that, oh, this is not scary, they touch it a lot and they played a lot with robot. But then they get bored with that robot and the interaction decreases systematically. But through the behavioral analysis, we found, again, there are a few exceptions. And here is one exception. Interaction involving, haptic interaction involving robots' hands and arms did not follow this blue shape. So it just, those type of interaction lasted longer. So that's one of the reasons why I have been insisted the importance of these haptic interactions. Anyway, I think at some point I should wrap up. But at some opportunity, like a TED talk or something like that, so they are required to say in that way. As you know, that just recently these strong AI or robots attract huge public attentions. Of course, it's useful for some purposes. But we say that if our goal is to make humans happier, we also have another solution, meaning that these robots or computer applications are not strong. But as a result, those robots or computers could empower human capabilities. So this careless living robot is just one example. So I think that in our laboratory, we are now pursuing this type of computers or robots. Anyway, I think I also have some slides about remote teaching or some other type of robotic applications supporting childhood education, but I think I should stop. Yes. That's true. So maybe I should stop at this moment. Thank you.
You guys have any direct questions?
I have more like, it's a question. The QRIO robot.
Mm-hmm.
You compared the QRIO robot with the auto robot, and you showed that the QRIO robot was better. But what was the other robot?
That was not a robot. So that's a robotic toy.
Okay, yes.
So I can, okay, you can see that here there is a pretty much in the United States, these robots are elsewhere. This is a toy robot we can buy at any stores. So we did a comparison between these toys.
Okay, so they look more, they have a similar
appearance.
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 Okay, great.